In each of the previous problems, we have been finding the terms by substituting n equals 1, 2, 3, 4, etc. With recursive sequences, rather than finding the nth term by substituting in values for n, we find each term based on the terms before it. This is a different type of sequence that we're going to be looking at, and you actually have to be given a formula on how to generate the terms. This is kind of a side field trip. We mentioned this for a little while, but we're going to go back to substituting in values 1 through 4. But we do need to learn about this. So again, we are being asked to find the first 5 terms this time, and we have the value of d1. We have our first term, d1 is equal to 30. What we need to be able to do is read this formula right here. This says the nth term is 1/3 the n minus first term minus 1. In other words, each term is 1 less than 1/3 the previous term. See, when you're looking at these subscripts, n and n minus 1, I like to say that the n minus first term is the previous term. So we have the current term is 1/3 the previous term minus 1. So when we're going to find d sub 2, n is 2, we will have 1/3 n minus 1, the first term. So we will have 1/3 of the 30 which gets substituted in, then minus 1. This is 10 minus 1, which is equal to 9. To find the third term, d sub 3, that will be 1/3 the previous term, which was 9. That's 3 minus 1, which is equal to 2. To find the fourth term, we will have 1/3 of 2, which was the previous term. 2/3 take away 1 is negative 1/3. And then finally, to find the fifth term, it will be 1/3 times negative 1/3 minus 1. That will become 1/9 minus 1. That will be negative 1/9 minus 1, which will become negative 10/9. Notice we cannot find that fifth term by substituting in n equals 5. We can only generate that fifth term by going through the first through fourth terms. Again, we are being asked to find the first 5 terms. When I read this formula right here, I see that the nth term is 10 minus the previous term. So I'm going to say the previous term subtracted from 10. So you basically need to know how to be able to read this formula. We are given that the first term is 7. To generate the second term, we will subtract that 7 from the 10 to get 3. To get the third term, we will start with 10, subtract the previous term 3 to get 7, and so on. The fourth term will be 10 minus 7, which is 3, and the fifth term will be 10 minus the 3, which will equal 7. So we have kind of a fun, if you can call it, sequence where it alternates back and forth between 7, 3, 7, 3, 7, 3, etc. Each of the odd indexed terms will be 7, and each of those with an even subscript will be equal to 3. This next sequence is a very famous sequence called the Fibonacci sequence. We are given the first 2 terms, which are each going to be 1. Now, reading this formula, we find that the nth term is equal to the sum of the n minus first and n minus second term. In other words, you're going to add the 2 previous terms to get to the next term. So in this pattern here, we begin with 1 and 1. They add up to 2. Adding 1 and 2 together, we get 3. Adding 2 and 3 together, we get 5. There's my first 5 terms, but this is fun, so let's keep going. 3 plus 5 is 8. 5 plus 8 will become 13, etc. So this is known as the Fibonacci sequence.